All right, welcome to Frank Teaches DevOps. Okay, in this series, this an episode. In this episode, I will be describing how, um, as a DevOps engineer or anyone with the skill sets could monitor a Kubernetes cluster and the objects, all right, that runs on a Kubernetes cluster with the ELK stack. Okay, so here's the ELK stack. So ELK is an acronym for Elasticsearch, Logstash, and Kibana. It is an acronym for Elasticsearch, Logstash, and Kibana. All right. Um, we have a lot of diagrams, different diagrams on the internet about ELK, Elasticsearch. All right, so many. If we go on Google now, we come here and say monitoring Kubernetes with ELK. You see a lot of diagrams, so many diagrams. All right, trying to describe, explain ELK stack. Okay, if I look at this, we have this Elasticsearch, Kibana, APIM server, bit, all right, which is file bit. At this other end, we also have, but this bit, sorry, this bit is different from file bit. We also have file bits and metric bits. At this monitoring end, we have Elasticsearch and Kibana. All right, so there's a lot, and at somewhere here there is Elastic Cloud. Okay, there's Elastic Cloud, then there is ELK standalone. Okay, all right. So, what is Elasticsearch? What's Elasticsearch? What is Logstash? And what is Kibana? And in between, what makes all of these? What brings all of these pieces together? They are the agents. So the agents in this diagram, they've used bits. Okay, so on this diagram, they've used something called bit, BAT. So bit agent is the agent that collects the the data, the atomic data running on this specified node. All right, let's assume we have this is a pod. Let's call this is an Nginx pod, and here is an Apache pod. Then like this icon is Jaguar, something like that. All right. Now on this board, you have a bit agent that monitors the activities of the Nginx pod, and this bit is responsible for collating the information. All right, in forms of in the form of log. All right, and pass that information into Logstash. All right, so Logstash is responsible for collecting the logs, all right, from the agent. The agent could be bit, so in this case is bit. It could also be file bit. It could also be metric bit, right? So these are all agents. That's forward log on the running pod, all right, to Logstash, and Logstash in turn forward these logs to a central store. In this context, Elasticsearch, Elasticsearch acts in the capacity of a storage. All right, okay, and from Elasticsearch, um, Kibana collects from Elasticsearch. It searches for um, maybe the index created, all right, searches for a particular pattern, and it displays that pattern on on a graph, or as the case may be. All right, so let's look at properly what Logstash is, Elasticsearch, and Kibana. So if we go back to Google, and we say Logstash. Now, Logstash is a free open source server side data processing pipeline that ingests data from a multitude of sources, transform it, and then sends it to your Elasticsearch. There should be Elasticsearch. Let's see. And send this to your favorite starch. All right. Now, if we come back to our diagram, okay, so it collects the necessary data from different sources. So it's collecting data from Nginx pod, Apache pod, and Jaguar. All right, Jaguar pod, and is forwarding those logs, which is ingesting the log into Elasticsearch. So Elasticsearch is acting as a data store. So let's see what we have on Elasticsearch. Okay, products Elasticsearch. What do they say Elasticsearch is? Now, Elasticsearch is a distributed JSON-based search and analytics engine. All right. Now, um, from yeah, so the data is now stored in an Elasticsearch. All right. So going forward, Kibana takes those data, all right, and displays those data on its own dashboard. So let's see what they say about Kibana. So Kibana gives shape to your data and is an extensible user interface. So Kibana is the UI that displays what Elasticsearch has. All right. So going forward on Kibana, you can now start doing things like querying of data, right? Querying of logs. So those query are coming from your Elastic Search, right? Elasticsearch. So keep it in mind. Keep it in mind that Logstash is for data log ingestion. So where does the logs goes into? They go into Elasticsearch, right? Then Logstash is also responsible for collecting of data, all right, from the bits. It could be file bits, it could be metric bits, and the bit itself. Okay, so that's that about ELK. That's about ELK. So this is the flow from the bits from the pod, which is it could be pod, it could be system, it could be VM instance. All right. So from that instance, all right, bits runs on the instance already, and it collects the information and forwards it toward Logstash. Logstash in turn forwards those information, all right, to Elasticsearch for storage. Then Elasticsearch, Kibana collects those data for visualization. All right, for visualization. Okay, so we'll go into the next phase, which is what demonstration. So in this demo, I'm going to show us how all of these is actualized. How all of these is actual. Okay, so I have to make it more clearer is just the same thing here, but in here is kind of linear to make the picture more clearer. So we have Bit, Logstash, Elasticsearch, and Kibana. So Bit is the data collector, all right? So from this diagram, Bit collects the data from the Nginx node, all right, and pass the data to Logstash. So Logstash is a data aggregator, all right? It does data aggregation and processing. Okay, then it pass those data to Elasticsearch for storage and then indexing. Okay, those data will be on your Elasticsearch. until they are required by Kibana. Okay, Kibana is mainly for analysis and visualization. So quickly, without further ado, um, let's um, let's see how we can set up this monitoring on my Kubernetes cluster. Okay, so if let me check if my cluster is up queue. Let's say AWS STS um, get caller ID. Let's see. Oh, Frank is still logged on. So if I say Q CTL get nodes. All right. I have a Kubernetes cluster of two worker nodes, one cluster with two worker nodes. So yeah, so it's a bare cluster, it's a bare cluster. All right. Okay, so what we're gonna do now is I have my files, my I have the file, the YAML files for the bits, Logstash, Elasticsearch, and Kibana. I have them on my GitHub repository already set up and configured. Okay, I have the Kubernetes manifest for file bits, file bits, file bits, metrics bits, and log stash. Okay, elastic search, and Kibana. I have all of these manifests on my GitHub repository. So I'll also be sharing my GitHub repository. So my GitHub repository is here. Um, Kubernetes. So this is my GitHub repository. You go to monitoring. All right. So I have for ELK stack. There's also Kibana. There's also Prometheus and Grafana. But today's episode is solely for ELK stack. So let's clone this repository. Copy, clone this repository. Go back. Then I will say clone, git clone what that repository. All right. So I'm cloning. So I just clone the repository called Kubernetes. Okay. All right. So I'll go into the directory Kubernetes. I have monitoring. Go into monitoring. I have Kubernetes ELK. Kubernetes ELK. So inside of this file, I have these YAML files: Elasticsearch file bit, Kibana, Logstash, metric bit. Okay, so I'll just take my time and open each of these files and go through it one after the other because of time as well. So let's start with Elasticsearch. So Elasticsearch, you can see I've created a service account. Okay, service account, and look, mostly all of these I've taken all of these from the original documentation of Elastic. All right, of Elastic Stack themselves. So I have also tried to. I took the whole of the YAML of the manifest, Kubernetes manifest from the developer, which is Elastic. All right. So this is the file as it is. Okay. This is all that I got from Elasticsearch themselves. Okay. Then the same thing is for file bits, metric bits, and all of that. Okay, and all of that. All right. and all of that. So this manifest has already been written by Elastic Stack themselves. Okay, so just to go ahead, the only thing you need to just do is just to run the kubectl apply, and it will create each of these files. All right. So the first file I'm going to create is the first deployment. All right. The object I'm going to create is my Elasticsearch. So let's look at the Elasticsearch one more time. So in here, I'm creating a service account, and the name of the service account is Elasticsearch, and I'm going to create all of that in this namespace cube system, and these are labels. All right. Then I'm going to create a cluster role. Then also, I'm giving the cluster role a name, Elasticsearch, as well. I'm also targeting the same labels I create here is the same label they created here as well. Okay, and yeah, there's other parameters as well. Okay, so I'm going to use my kubectl apply and create this this deployment, Elasticsearch deployment. So if I say, so I'm going to say kubectl apply minus f Elasticsearch. All right. So if you see from our diagram, the first thing we need to create is Elasticsearch. All right. Elasticsearch has most of the components that Logstash will need. All right. Logstash will need. So I will need to create Elasticsearch. Then once Elasticsearch is created, I may also need to check if Elasticsearch is working. Okay. So let's go back and then hit enter. Hit enter. All right. So it's going to tell me I had this already. So it's saying service account unchanged, cluster role unchanged, cluster role binding as well unchanged because I did this sometime. Then stateful sets is being created. Then service, Elasticsearch service is being created. So at this point, if I say kubectl get service in this namespace, cube system. So I'm going to see my Elasticsearch being created, and the node port is 31335, 31335, and the type is node ports. All right. So let's see if I can access my Elasticsearch from the internet. So all I need to do, I'll go back to my portal, AWS. Then I'm going to take one of these nodes. All right. So kubectl gets node o wide. Okay. I'm going to take one of these nodes. Okay. This node's IP, either of these node IP. I'll copy it. Mind you, we exposed Elasticsearch on port 31335. So that has been copied. Come here, paste it, 31335. If all goes well, we should, okay. I think that port might not be open yet. So yeah, let's, which is worker one, EKS worker one. All right, go to security. Okay, okay, okay. I may need to attach my security group. All right, click on the EC2 instance, come to actions, go to security, click on change security groups, and I need to add my security group, which is this security group which I used. Click on add security group, and that's all. Click on save. Okay, so the next thing I need to do, I need to open the ports 31355 on this security group. So click on this security group and go to edit inbound rules, and at the bottom we can click on add a rule, custom TCP. Okay, this, and save. So now let's go and check our Elasticsearch. All right, great. So now you can see that we are now getting response from the Elasticsearch. So Elasticsearch is up and running. Okay. So the next component we shall run is the log stash. Let's see. So Elasticsearch is the log stash. Okay, so the log stash acts as a bridge. Okay, it acts as a bridge. The log stash acts as a bridge between the bits and Elasticsearch. The log stash is a bridge between the bits, which are the file bits and metrics bits, and it acts as a bridge between the bits and Elasticsearch. Okay, so the next on our table is deploying what log stash. So let's go and see that. So let's look into log stash. Deployment file. So I'm setting a config map here. This is it. Same. Then yeah, log stash runs on ports. These are the configuration for the log stash. All of these I've copied from the developer. I took from the developer, which is Elastic, and yeah. So this is everything. Okay, this is everything. Okay, so quit and use your kubectl apply minus f and log stash. So this is going to create a log stash service. So this log stash service is going to be moving the data from log stash into the data store, which is Elasticsearch. So come back and config map on change, deployment created, and service also created. So if I say kubectl get service in namespace kube system, I should get the log stash running and that of Elasticsearch. So if I also do kubectl get port in this namespace cube system, I should get my port running. So I have the Elasticsearch port running as a stateful set, all right, as a stateful set, and this is log stash as a deployment. So now you can deploy your ports as stateful sets, and at the same time you can deploy your ports as a deployment. All right. So there are there's a slight difference. They do the same thing. A deployment and a stateful set, they do the same thing, but there's a slight difference. There's a slight difference in the terms of indexing. All right. So for a stateful set, what a stateful set does is it represents your ports with an index of zero, starting from zero, one, depending on the number of replicas you've defined in the stateful set manifest. Okay, so if I've defined four replicas, okay, I'll have zero, one, two, three, as like this. Okay, like this. But if it is a deployment is going to come up with a random alphanumeric numbers, all right, at the end of the deployment name of the sorry the port name. So this is how you know which is a stateful set and which is a deployment. A stateful set comes like this 0 1, while a deployment comes in this fashion. Okay, all right, great. So now that we have set up our log stash, let's go ahead and um, create the file bits as well as the metrics bits. So the file bits pick um, um, will pick those information relating to system level information. We'll also pick information from at the syslog. That's what the 5 bits will do. All right, we pick logs from the system log. Okay, but the metrics bits will pick critical metrics like the CPU, the RAM, the the disk IO. Let's see how it's defined in let's see the file bit, the manifest for the file bit. What and what this manifest this file bit does. Okay, what does it do? Let's see the resources it picks. Let's see. Okay, user resources, namespace, port, verbs. Okay, get, watch, and list. Let's see. Okay, that's all. Oh, 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 oh. Mhm. Okay, like I said earlier, these manifests I've collected it from Elastic, Elastic itself. Okay, so the next thing I'll do, I'll deploy. I'll create the file bits um, agents on the cluster. Okay, hit the file bits, kubectl apply minus elf file bits created. So if I say kubectl get, okay, daemon set get ports in namespace cube system. This is from file bits, so the port is running from file bits. Okay, great, great. Okay, so the second to the next one will be the metric bit. So let's see what metric bit has. I'm going to into the file metric bit.yaml. Okay, so what metrics am I getting from my cluster? So can you see these are the metric sets? All right, CPU load, memory, network, process, summary. These are all the metrics I need to catch. Okay, from the ports in my cluster. Okay, all right. So I'm going to run this as well. Kubectl apply minus f, then metrics. All right, great. So metrics has been created. So if we go ahead and run kubectl get ports in namespace cube system, we should get the agents already running. You can see this is the metric bit agent already running. We also have the file bit agent already running. So we also have the Logstash pod as well as the Elasticsearch pod running. So the last on our list will be Kibana, right? So Kibana. So let's look at our deployment for Kibana. All right, it's the same thing as that of Elasticsearch. It's the same thing as that of Elasticsearch. So the same thing, all right. Like I always pointed out, I've picked all of these from Elastic website. All right. So Notepod is going to run. Kibana is going to run on 31.3.3.6. I've also created a service because ordinarily you cannot access Kibana um, from outside the cluster. Okay, but for you to be able to access Kibana from outside the cluster, you need to create a service and expose that service and set it as a node port. Okay, and the port number is 31336. All right, so we'll do the same thing. We'll say kubectl apply minus f Kibana. All right, so let's see. All right, great. Deployment created and service also what created. So if I now say kubectl get service in namespace cube system, cube system, I should get Kibana service running on 31336. So all I need to do is the same way get node, all right, o y. Okay, copy my node ip. Here's my node ip. Copy it, go to your browser, paste it, column 31336. This will not go because this port is not open on our security group. So all I need to do is I may have to go and open this port 31336 on my security group. So here's my security group. Where is the security group? Okay, edit inbound rule, and I'm going to add custom TCP 31336. Okay, save and quit. Yes, so if I go back to my URL, refresh, I should have Kibana loading. All right, Kibana is loading. So this is my Kibana dashboard. All right, in UI, sorry, Kibana UI. All right, so I'm accessing this Kibana UI from my cluster from my cluster. This is where I'm accessing the UI from in the cluster. So the next thing I need to do is just to create an index pattern. So come here. So manage and administer Elastic Stack. Click on index pattern. Okay. So automatically it picks up log starch and metric bit. It has already picked it up already. So you can see your index can match any of your two indices below. All right, so all I need to do, I just need to copy this my index here, copy it, bring it here, paste it there. Success, your index pattern matches one index. So I'll click on what next. All right, so click on next, and the next thing you need to do, you need to define a timestamp. All right, time filter field name, call it a time stamp, and click on what create index pattern. So the moment you create index, click on create index pattern, you should get something Vowler. All right. So this is what you need to get. So once these are all these are the name based on timestamp. All right. GeoIP, geolocation. There are lots. All right. So once you've done that, go to what discover. Click on discover, and this is your Kibana. Kibana now is now picking at this juncture. Kibana is communicating with Elasticsearch. Kibana is now has pulled the whole data, all right, on Elasticsearch into Kibana. So Kibana is now communicating back and forth with the Elasticsearch. So all of these you're seeing is actually coming from Elasticsearch itself. So for instance now, let me deploy a quick application, a quick pod, okay? But we can monitor it, we can check the logs of a pod. Let me get my pods. Keep it here, get pods. Namespace, cube system, cube system. Now, I want to get the logs from core DNS, all right? This is a pod called DNS. This is this pod name. I'll copy that pod, come here, come to my search term. I'll paste it. Now take note of this number, the number of hits. All right. So I'll click on what search. Search. There are 0 hits for this pod. Now let's go back. Um, Nothing. This guy has not generated any log. Let's look for okay. Let's look for file bits. Let's look for this file bit. Copy that. Bring it here. Paste it. Search. It's taking some time. It's trying to pull the data. It's trying to pull it down. Okay, great. So you can see now, this is 601, 601 bit hits, right? From this pod, file bit. So these are the logs from file bits. These are the logs. But let me do something much more practical. All right. I'm going to spin a an Nginx pod, a simple web application, all right, and 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 try and see how I can access the logs coming from that pod. So I'll pause this video and I'll be right back. Not really, okay. So let's search for a simple Nginx um, Kubernetes pod. Kubernetes simple Nginx pod. Very simple and quick. Let me see. No. Okay. Simple Nginx. Very simple. Where is it now? I need a simple application. Simple Nginx application. Simple Nginx deployment. It's not deployment though. Kubernetes. Let me check. Let me check. All right, let me pause the video while I'm looking for. Okay, this is a simple Nginx, deploying a sample Nginx app on a cluster using kubectl. All right, so let me just copy this URL, this link, copy it, come to my cluster, and then download the file. Download that file, download it. So let me download that deployment, then rename it to from deployment to nginx.yaml. All right. So now I can now create. Let me check the namespace. Nginx. Which namespace? So it's going to go into default namespace. Okay, it's going to go into default namespace. Nginx deploy. All right, that's fine. Um, okay, so I'll say kubectl applied minus f nginx. So let's see if everything goes well. Let's see, deployment created. So if I say kubectl get port, this should yes. So in the default namespace, I have my nginx pod running. Okay, so this is it. Nginx pod running. So now I want to search for this pod. I want to look at the logs coming from that pod. So let's see, go back to our Kibana. Okay, so come here, paste that nginx and click on search. Let's see. Whoa, 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 whoa. No result found. Okay, nothing yet. Let's refresh that. Okay, no hits. Take some time. Take some time. Let me copy this. Copy. All right. So this is the way anyway. This is how you get the logs of okay, showing past 15 minutes. There was nothing past 15 minutes. Let me just say today, um, 1 hour relative. Let's check. This is past 20 seconds. 20 seconds. Let's check. Nothing. Last 20 seconds. All right. All right. So this is how you make Kibana to monitor your resources on Kubernetes cluster. I hope this video has been very informative, and I thank you for watching. Please kindly like, share, and also leave your comments. Thank you and have a nice day.